Hello dear friends, welcome to the channel. Today we are going to learn the topic Moore and Mealy machine. In Moore machine and Mealy machine, they both we can call them as a machine which is a similar to DFA and NFA. So what is DFA? Is a deterministic finite automata where we have a machine with the 5 tuples, okay, which is basically a acceptor type of a machine which will always tell you positive or negative result. That if you want to check whether the string is starting with so and so, or is it ending with so and so, or string containing even number of zeros, or whether the string has a particular substring or not, so it will always give you yes or no type of answer. But Moore and Mealy are the different type of machine where the answer is not always yes and no. The answer will be some output that you want to derive from it. Okay, so let's start with it. And that's why this machine is similar to DFA, other than only one thing, that it is giving you an output. It will have a tuple which is giving some output. That's why the tuple definition, if you see here, so in this tuple definition, this Moore machine, M is equal to Q sigma capital delta, small delta, lambda and q0, where q is a finite set of states. This is altogether same as what we have in DFA. Sigma is also finite set of input symbols. It is same as DFA. This capital delta is a new thing here. Okay. Now what happens in capital delta? It is a finite set of output symbols. Means whatever output we are supposed to get by this machine, that symbol will go into the output symbol. Now you will say that input and output symbol can be similar. Yeah, sometimes they can be similar, but sometimes they can be different. So that's why we will always have them defined separately. That is, input symbol will be defined in sigma and output symbol will be defined in capital delta. Then we have a transition function which is again same as your DFA. Okay, and the function is also same, that is q cross sigma gives q. Then we have this lambda here. So now because we have our output symbols considered, the machine will also not just moving from one state to other state. The machine is also giving you some output associated with every transition that is happening. So here there will be some output which we are getting. So every state gives us some output, and that's why if you see the lambda is machine function, which is nothing but the output that is given to us. So these are the two new tuples which we have over here, machine function. So here machine function is given as lambda, and that says q gives delta. That means q gives delta means we can say that every state has one output associated with it. So I can say every state has a unique output associated with it, right? So if I have 5 states, I will have 5 outputs, like that we can say, and every state has one fixed output. So if you go to that state, then that means you have this output. So if I stop my Moore machine at particular point, I can say this is that state, whatever output it is giving, that is my final output. Okay, q0 again is the same as the initial state. The one state which is removed from this is nothing but a capital F, that is a final state. So final state will not be there in Moore and Mealy machine, because final state is there in DF and NFA. So which is a final state? If you reach the final state, is accepting. If you don't reach the final state, it is not accepting, right? But here there is nothing called as accepting or rejecting. Here we have only outputs, and that's why we have no final state. And instead of that, we have two new tuples and which are associated with the output. One is a capital delta, which gives us output symbol. Okay, sorry, yeah, and the other is a lambda, which gives us a output machine function. Okay, now without wasting much time, let's start with one example and understand how this Moore machine works. Okay, now the question is, design a Moore and Mealy machine for a binary input sequence. That means we have to take as an input, the sigma is going to be, the input symbols are going to be, the input symbols are going to be 0 and 1. So I can say here sigma will be 0 and 1. This is set of input symbols such that it has a substring 0 1 1. Okay, now if the machine has a substring 0, if the particular string has a substring 0 1 1, then it is supposed to give the 0 1 1. Then it is supposed to give the output A, and if it has a substring 0 0 1, then it is supposed to give the output B. That means we are interested in getting the outputs either A or B. So that's why I can say my output symbol will have A or B. But what if my string is not having output A or B? It will have some other output, and I can say that output is, say for example, C. Okay, or you can say X. So here if the output is given by the model, you have to just write it as it is. But here C I am taking myself. So I can just give an explanation for C that output when string not containing 0 0 1 or 0 1 1, right? So otherwise we will have this output, right? So this way we can give the explanation for whatever output you are assuming. So here if no output is given and I am assuming myself the output, I will write yeah, output is true or false, and I will have to give the explanation what does true means, what does false means. Okay, now let's start with the developing the model. So when we are developing a model, as I told you, this state transition function delta is same as DFA. You can see here, and that's why we will start developing the model considering it is a DFA. So if I am going to construct a model for DFA, which is checking that it has a substring 0 1 1. Okay, let's try to develop a DFA for checking whether it has a substring 0 1 1. How do we will go ahead and make this DFA? Let's start with it. Okay, so I will have some state here. I will have some state that is Q0, and then I have to check whether it is containing 0 0 1. So I will say 0 0 1. So Q0, Q1, Q2, Q3. Just give me a minute. Okay, fine. I'll make it little bigger. States I'll draw a little bigger. Yeah, this is Q0, Q1, Q2, Q3, say for example. So now this particular can be the smallest DFA that is containing 0 0 1 or not. So I will draw it as a NFA, say for example, that is if it is having this 0 0 1, that means that state Q3 it is having you can say the state Q3, we can say yes, the string contains substring 0 0 1. Once I get 0 0 1, after that I can have n number of say for example, I was at Q0, I got 0, then I got 0, then I got 1. I reach Q3 now, right? Then after that I have so many zeros or so many ones or anything. It doesn't matter at all because the string has already qualified the condition of containing 0 0 1, and that is done once. That means you whatever comes after that, you are already containing 0 0 1. So I can say here once I reach Q3 and if I get n number of zeros and ones in any combination, I can say it is having already string 0 0 1. So whenever you are in Q3, you can say I am having 0 0 1, and that's why I am supposed to give what output if I am having 0 0 1. If I am having 0 0 1, I am supposed to give output B. So I will give the output B when I am at Q3. So when I am at Q3, I get the output B. Okay. Now let's come to the other part of it. Now what is the other part? If I am having the substring 0 1 1, then the output is supposed to be A. Now I'm at this particular state now. From Q0 to Q1 I have the output uh, 0, input 0. I want to check 0 1 1, then it will say A, right? If it is 0 1 1, then it will say A. So 0, after that, instead of taking this 0, after that 0, if I get 1, I will go to some another state. And then if I get 1, I will go to some another state. Getting it? So Q0, Q1, Q2, Q3. Now this is Q4 and this is Q5. Okay. So now if I am at Q5, I can say my string is containing 0 1 1. And here after this, if I get n number of zeros and ones, I'm still having this 0 1 1 criteria fulfilled. And that's why I can say at this particular stage, we got the string which we can say it as a type A, right? And then we can give the name to other string. Now what are the remaining states are not fulfilling your criteria, and we will give them the remaining otherwise type of output, and that otherwise remaining output is C, that will give to all the remaining states. And this way we got this particular thing done. So I hope this is clear. Okay, now here there are many chances that later you will have, say for example, um, 0 1 0. Now I'm adding more transitions to this model. Say for example 0 0 1 1 is a string that you are getting. Okay, if it is starting with 1 altogether, then there is no point. That means from Q0, if you are starting with 1, is not going anywhere. It is going to dead state, and we are not showing any dead state transitions. I'm just avoiding that. At Q1 you are having both values for 0 and 1, so that is covered. But at Q2 you are having only transition for 1. But at Q2 if 0 comes, what happens? So at Q2 if 0 comes, what will happen? You will have 0 0 0. But after that if 1 is coming, then it is having 0 0 1. So if 0 comes here, I will keep it on the same place. That means 0 0 0 0, n number of zeros will come at Q2. But then after that if it is having 1, I can say it is having substring 0 0 1. So that is taken care. Q3 also 0 and 1 both are going. From Q4 only 1 is going. So from Q4 if I get 0, what will happen? Okay, so at Q4 if I am getting 0, that means at Q4 what is the string that I am reading? 0 1. So when I read 0 1, I reach Q4. And at Q4 if I want to read 0, the string becomes 0 1 0, right? So 0 1 0 uh, is later, can this 0 can later have substring as 0 0 1, or this 0 can have later substring as 1 1. So that means this 0 we will consider as the initial 0, and that's why this initial 0, when I read first 0, I am at state Q1, and that's why from Q4 if I get 0, I will go to this place. That means after this 0, if I get 0 1, I am going to Q3. If I get 1 1, I am going to Q5, right? So this is the case, and at Q5 I am reading both zeros and ones. So with this we are done with this model, and this model we can call it as a Moore machine for the given question. So once this is clear, we can now fill the values for all the parameters that have been explained in this tuple definition. So what is a Q, what is a sigma, what is a transition function, how do we write the machine function, and initial state. Okay, so let's write it for the entire model. Now I can say capital Q is a set of all the states, right? So what is it? What is set of all the states? Till Q5. So I can say Q0, Q1, Q2, Q3, Q4, Q5. What is sigma? Input symbols 0, 1. What is delta? We have already written up. That's why, yeah, A, B and C. What is A, what is B, what is C, that you have to write, huh? Then we have this delta, which is nothing but a transition function. Q cross sigma is equal to Q. Yeah. And so here I will draw the table for it. So q cross sigma, what is sigma? 0 and 1 are the input symbols. Q cross sigma. What is q? All the states, that is q0, q1, q2, q3, q4 and q5. Here we will show only initial state, we will not show any final state, because Moore and Mealy machine there is no final states, right? So now the table will look like something like this. Okay, now we have written all the values. Now next we will have this lambda, which is a machine function. We also call it as a MAF. This one we call it as a state function, which is STF. Okay, so machine function is written as lambda is q gives delta. That means every state has some output associated with it. Okay, I have what are the states that I have? Q0 to Q5. So this is going to be my machine function table, where Q0 is the initial state. Here Q3 has output A, Q5 has output B. Rest all the states has output associated as C. So that is what is my machine function table. Okay, and here your initial state was q0 only. So this is all about the Moore machine. I hope you understand this particular thing. Okay, so now let's see how do we develop the Mealy machine for the same. So this is a Mealy machine where we have this tuples. The tuples are all same as your Moore machine, but only differences here is this particular lambda. Okay, so now lambda is different in this Mealy machine. What is lambda? Q cross sigma gives output delta, right? There only q was giving delta, so there the output was associated with the state. Here the output is associated with input state and input symbol. I hope you're getting the difference. So there every state has one output associated with. But here every state with respect to what input it is taking is giving you output. That means basically here the output is associated with every transition. When I say q cross sigma is nothing but one transition that is going from one state to other state. Okay, so now if I want to develop the Mealy machine for the same, the diagram will have the similar structure but only little differences that we'll see now. Okay, so this is going to be my Mealy machine. You can see the structure is completely same which I have done, and the difference that I have made is with respect to the output. Here output is not associated with the state, so the output is associated with respect to every transition. That means if I am at Q0 and I get input symbol 0, what is going to be output? So Q0 by 0 is this particular transition shows that particular combination, and for that particular combination where I am going to Q1, but if I am going to Q1 I am not getting output A or B. What output I am getting? C. So basically this transition will give me output C. So now which transition will give me output A? That means when I am going from Q2 to Q3, that means I am reading 0 0 1, and when I am reading 0 0 1 at this last one I am going to Q3. So the transitions which are coming towards Q3 are giving you output B. Similarly, these self transitions are also going to Q3. These are also giving you output B. Which transitions are giving you output A? Those which are going to Q5. So what is incoming transition to Q5? This one is giving you output A. Similarly, this self loop are also giving you output A. Remaining all the transitions are giving you output C, which is a otherwise case. Here in this particular example, we have seen that the Moore and Mealy machine, both the diagrams were exactly same, only the representation was output was little different. But that will not be the case in all the conditions. Yeah, sometimes we will have some examples where we will have the Mealy machine having very small diagram or smaller number of states, and Moore machine will need more number of states. So that can be the combination sometime, that can be the possibility sometime depending on the question, but the way and strategy of doing the same is almost same. Okay, now in Mealy machine the tuple definition is also written in the same way. So here the state transition function which you are making which is Q is equal to Q cross sigma gives Q. Yeah. So this is going to be same as what we have done in Moore machine, because if you can see the function is also same, but the machine function is different here. So machine function is Q cross sigma gives delta, and that is different, and that's why this table is going to look little different in terms of melay machine. Now what does it state? What is there on the input side? Q cross sigma. So that's why we will write Q cross sigma. Sigma is 0, 1 and Q is Q0 to Q5. Right? Here we have one input function, input state. There is no output state. Now what is going to be the output? Output is going to be delta. And what is delta? Delta is something from A, B and C. That means Q0 on 0 gives you what output? So Q0 on 0 gives you output C. Right? Q0 on 1 is also going to date state, and which is not giving you any output. So that means it is giving you otherwise C. Q1 on, now which is giving you output A. Q4 on A gives you output. Q4 on 1 gives you output A, that we can see here. So Q4 on 1 gives you output A. Q5 on 0 and 1 both gives you output A. What is giving you output B? Q2 on 1 giving you output B. And Q3 on 0 and 1 giving you output B. Rest all the states are giving you output C. So this way we can write a MAF or machine function or the lambda function table for melay machine. So that's it with this particular example, understanding what is Moore and melay machine and how do we make the solve this questions. Thank you.